Hi there, welcome back. In this video, we're going to be looking at two nonlinear dimensionality reduction techniques, and we're going to see whether they can improve the accuracy of our baseline machine learning model, which is, in this case, a logistic regression. In a previous video, we looked at linear transformation techniques, we looked at PCA, we looked at SVD, and we looked at LDA. And in this video, we're going to look at nonlinear transformation techniques and see whether we can get some improvements of our results, of our accuracy for a baseline logistic regression model. So let's go ahead and do that. But before I start, I just want to thank you guys for checking this video out, for subscribing to our channel, as we really want to help you guys grow in the data science and machine learning space. So don't forget to click that subscribe button and check out our other videos, and hopefully you're gonna get some value out of the content that I put on this channel. Okay, so let's go ahead and check out our nonlinear dimensionality reduction techniques. So the first one that we're going to look at is an Isomap embedding. But first, just to give you a refresher, what we did previously in the previous video, and I'm going to put down a link below where I talk about the linear dimensionality reduction techniques. But let's just go ahead and see exactly what we did previously. What we created a data set using make classification from scikit-learn, where we created a data set of 10,000 records, and we had 30 features, of which 20 were informative and 10 redundant. And if we look at the shape, we have 10,000 records and 30 features. And then we trained our logistic regression, and we got an accuracy of 81.7. Let's run this again just so that we make sure that we get the same, but we should get, because we have set the random state for our cross-validation. So again, our accuracy is 81.7%. So we went through our linears in the previous video. So now let's look at the nonlinear transformations. And as I was saying, the first one is an Isomap embedding. And Isomap embedding is a nonlinear dimensionality reduction technique. So this is unsupervised, okay? That creates an embedding of the data set and then tries to preserve the relationships in that specific data set. Isomap looks for a lower dimensional embedding which maintains the distance between all points. So let's look at the documentation real quick, and we can find a lot of information about different techniques that are specific to manifold learning. So we have our Isomap and locally linear embedding, which I'm going to show later on. What we're going to do now, we're going to create a pipeline that will consist of two steps. First, we're going to create our dimensionality reduction technique with Isomap, and then we're going to add the model to our pipeline. And then let's run this. And if we're going to use cross-validation, we're going to use a repeated stratified k-fold validation. So we're going to use 5 splits and then 2 repeats. And then we're going to cross-validate it on the x and y sets. And we're going to use accuracy, exactly what we did previously here when we trained our logistic regression. Okay, so this is the same code, just that instead of the model, we have our pipeline. Let's go to our Isomap embedding, and if we would run this, we would eventually get an accuracy of 0.88 with a standard of 0.008. The only challenge here is that nonlinear dimensionality reduction techniques take a very long time to run, and in this case it takes around 8 minutes and 32 seconds on my machine. So the main takeaway here is that nonlinear approaches, when it comes to dimensionality reduction for our specific data set, they actually improve our results, improve our accuracy. So you see, in the previous video, in which I'm going to link down below in the description, we saw that we got, let me actually just go to the previous results. So we got, for our SVD, we got an accuracy of 81.7, exactly the same. For LDA, we got the same accuracy, 81.6, which is pretty much the same. And for the PCA, we got 81.7, which is the same. So you saw our linear dimensionality reduction techniques didn't really help with our data set, but nonlinear ones, which is Isomap, helped improve that. So we got a very, very good improvement in our model. So we got 88% compared to 81%. And that is beautiful, right? This is what was the main takeaway here. You need to try both linear and nonlinear dimensionality reduction techniques for your dataset, because you never know which one will actually fit better and help you improve the metrics for your specific problem, all right? And another one that I want to go through is the locally linear embedding. And this is also an unsupervised and non-linear dimensionality reduction technique that creates an embedding and tries to preserve the relationships between the neighborhoods in the dataset. And the reason why you would use LLE compared to Isomap is because LLE is more optimized and it can run faster. But definitely between LLE and Isomap, if you want speed, go for LLE, but I would recommend that you try out both and see which one is actually better for your particular dataset. If we would run this, of course, we create a pipeline. We're going to use the locally linear embedding from Scikit-learn Manifold. We have everything in the Manifold Learning section of the Scikit-learn documentation. Okay, so Isomap, and you can check more details about the implementation here, and also for the locally linear embedding. Let's go ahead and check this one out. We create our pipeline, and we have our local linear embedding with 20 components, and then of course our logistic regression. And then if we would try to check the accuracy of our cross-validation with repeated stratified k-fold, we would get an accuracy of 86.3%. But here, as you can see, our runtime is 7 minutes compared to 8 minutes. Again, if you want speed, if you can say speed, because anyway it takes a long time compared to linear models. If we check linear models, let's just look at LDA. LDA took like 759 milliseconds. It's almost nothing. And the same with all of these other guys, like SVD took even less, took half of that, and PCA took a little bit more, but nevertheless it's less than a second. It's crazy. It's so easy to run linear dimensionality reduction techniques, while the nonlinear ones take a little bit more time. So you have to be wary of that. But the main takeaway here is that definitely try out both linear and nonlinear. And the main reason why I put this video separately from the linear dimensionality reduction techniques is because I wanted to emphasize on the nonlinear dimensionality reduction technique. So definitely, whenever you have a problem, try out both linear and nonlinear, okay? I really hope that this video helped you, and I'll see you in the next one.